so I choose the topic nanotechnology. At the end of this topic, students should be able to first define the major potential and realize impacts of nanotechnology on society. Second, analyze nanotechnology through the conceptual ECS lenses. And last, examine the cost and benefits to society of nanotechnology. So, just how small is nano? In the international system of units, the perfect nano means 1 billion or 10 raised to negative 9. Therefore, 1 nanometer is 1 billion in meter. It's difficult to imagine just how small that is. So I have here some examples. A sheet of paper is about 10,000 of nanometers thick. A strand of human DNA is 2.5 nanometers in diameter. There are 25,400,000 nanometers in 1 inch. A human hair is approximately 80,000 to 10,000 nanometers wide. A single gold atom is about a third of nanometer in diameter. On a comparative scale, if the diameter of a marble is 1 nanometer, then the diameter of the Earth is 1 meter. And lastly, 1 nanometer is about as long as your fingernail grows in 1 second. Next, let's talk about nanoscience and nanotechnology. When we talk about nanoscience, it is the study of structures and materials on ultra-small scale and the unique and interesting properties these materials demonstrate. Nanoscience is cross-disciplinary, meaning scientists arrange fields including chemistry, physics, biology, medicine, computing, material science, and engineering using it to better understand our world. Next is the nanotechnology. Nanotechnology is the application of nanoscience leading to the use of new nanomaterials and nanoscience components in useful products. Nanotechnology eventually provides us with the ability to design custom-made materials and products with new enhanced properties, new nanoelectronics components, new types of smart medicines and sensors, and even interfaces between electronics and biological systems. These newborn scientific disciplines are situated at the interface between physics, material science, microelectronics, biochemistry, and biotechnology controlled of these disciplines. Therefore, requires an academic multidisciplinary scientific education. Although nanotechnology is a fairly new science that cheap concepts has developing over the course over 50 years interesting, may we have been employing nanotechnology for over 1,000 years, from painting to making steel. Although what has exchanged recently is our ability to manipulate and engineer at the nanometer scale. One of the most documented examples of nanotechnology known in history is medieval stained glass artisans. They were the first nanotechnology as they, although unaware, trap gold nanoparticles in the glass matrix in order to generate the rubbery red color in the windows. Medieval stained glass windows are examples of how technology was used in the pre-modern era. Stained glass windows were used dominantly in churches, and also found in domestic setting and public buildings such as town halls. Based on the latest researches, nanotechnology helps enhance the following quality. First is the biomaterials. Based on the latest research, biomaterials including tissue are artificial materials used for the repair, replace, and stimulation of biological systems. Nanotechnology involves the development and use of technologies that operate and the nanometer length scale around the science of a large biomolecule. Nanobiomaterials are being used in health such as imaging tools as bioengineering to detect diseases, monitoring, prevention, and treatment of several diseases. Next in line is the ceramics. Nanoceramics are type of nanoparticle first discovered in early 1980s. The good example of this is nanoceramics paint coating. This is being used in car painting coating to provide strong protection and shield to keep cars in shiny and to look brand new. A nanoceramic coating are scientifically formulated solution meant to penetrate microscopic imperfections, fill those gaps in the top range of the nanoscale, and provide a layer of protection that nearly is strong as solid. Third is the metals. Baseball bats, tennis, badminton rackets, bicycles, etc. are some of the sporting equipment whose performance and durability of being improved the help of nanotechnology. It increases the strength of the metal 200 times by rolling up the sheets of carbon atoms. Carbon atoms, however, also make a some of the strongest materials. Yes, strongest materials such as diamonds. In diamonds, carbon atoms are tightly packed together, making them so hard that they can cut steel. The fourth one is the polymers. To keep pace with the concept in a duration of computer chips, transistors must have increasingly small features. The use of carbon nanotube is one of the technology to maintain technology advancement by providing sensible approaches to smaller, faster transistors. Polymers technology has been used to strengthen computer chips, especially its design. So now let's move on to the nanotechnology commercial application. The first one is the sunscreen. Sunscreen provides protection from UV rays, possible use for nano-size zinc oxide and titanium oxide that reflects and absorbs UV rays and made it ultraviolet resistance. The second one is the self-cleaning windows. Self-cleaning windows are glass-coated with a vanadium dioxide nanoparticles, which make it ultra-resistant to water. The presence of conical sheet on the particles on the glass surface traps air and allows a minimal amount of water molecules to come up and to contact the glass surface. Therefore, when the rainwater hits the glass surface, it removes dirt and dust as it slides down.